students. Today we are going to see the derivation of electrode potential in electrochemistry. That is electrode potential. Derivation of electrode potential means you are going to calculate the EMF. Daniel cell means zinc copper cell. That is, this is the overall reaction which takes place in the zinc copper cell. For cathode, what is the reaction takes place in the cathode? Always reduction takes place. This is a reduction reaction. Why it is called as a reduction reaction? Since it is the addition of electrons. So ECU2 plus bar Cu is equal to E naught Cu2 plus bar Cu minus RT by 2F ln 1 by Cu2 plus. For anode, Zn2 plus gives Zn plus 2 electron. So what happens? This is our EMF value for this one. So now the cell potential, what is the cell potential? E is equal to E naught minus E naught. That is, EMF of the cell is equal to E naught of the reduction minus E naught of the oxidation minus E naught of the oxidation. So we can write like this. For that purpose only we are writing E naught comes one side, RT take this side. So minus RT no, so this becomes this minus RT ln and here plus, so minus. So EMF E naught of the cell is equal to minus, this overall term is called as a E naught of the cell, minus RT by 2F minus, so it becomes plus Zn2 plus by Cu2 plus. This is the overall reaction. That is, EMF of the cell is equal to E naught of the cell. This, to replace the ln, we know what is ln. Ln is equal to 2.303 log to the base 10. So we substitute the R value, F value, T value. That is, R value we know, T value we know. This is while converting the ln. What is ln is equal to 2.303 log to the base 10, log to the base 10. So this is the overall reaction. Substituting this, we can able to get the EMF of the cell is equal to E naught minus 0.0591 by 2 log of Zn2 plus by Cu2 plus. We can, if it is asked for 1 mark means, we can able to directly write this. From this equation, we can able to write E is equal to E naught minus to 0.0591. How many electrons transferred? 2 electron. Log concentration of a solid is 1. So product by reactant. This only we find here, no? EMF of the cell is equal to E naught of the cell minus 0.0591 log product concentration by reactant concentration. Similarly, for this reaction, how will you write? First write the overall reaction. What we discussed in the last class? That is, which one is written first is called as is placed in the reactant side, and this is also in the reactant side, and the next side, right hand side, should be in the product side. So nickel Ag plus product side, nickel 2 plus 2 Ag. How many electrons transferred? 2 electrons transferred. No, here it is only 1, so we need to put 2 here. Now write the EMF value. EMF of the cell is equal to E naught of the cell minus RT by NF. That is, N here is 2 ln we are writing in the ln, so no need to put 2.303. Product concentration solid is equal to 1. So product concentration by reactant concentration. Product concentration by reactant concentration. This is the overall reaction. And next we are going to see derive the equilibrium constant from Nernst equation. This is the same Daniel cell reaction. First, initially we have only the reactant concentration. No? As the time passes, what happens? Zn2 plus concentration increases in the product side and Cu2 plus concentration decreases in the reactant side. At the same time, voltage on the voltmeter is also decreases. That means concentration of the reactant decreases means the voltage is also decreases. After some time, there is no change in the concentration of this Cu2 plus and Zn2 plus. That means what happens? The equilibrium is attained and the voltmeter also shows the 0 value. This shows whether the reaction takes place or not. Yes, the reaction goes on. Both the forward and the backward reaction takes place simultaneously. But so that only the concentration of the reactant and the product remains constant. This already we discussed in the chemical kinetics, no? Chemical equilibrium also. So at equilibrium, what is the EMF value? 0. The voltmeter shows the 0 value, no? So 0. For Daniel cell, normally any cell, EMF of the cell is equal to E naught of the cell minus RT by NF ln product concentration by reactant concentration. Here the product concentration is Zn2 plus and the reactant concentration is Cu2 plus. Since the concentration of Zn solid is equal to copper solid equal to 1, both are equal to 1 unity. So what happens? E is equal to E naught of the cell minus ln means we know what is ln. Ln is equal to 2.303 log to the base 10. So log to the base 10. No need to put the 10 here. If it is 532 means we can able to put. So E naught of the cell is equal to E is equal to E of the cell, that is EMF of the cell is equal to E naught of the cell minus 2.303 RT by NF log of Zn2 plus by Cu2 plus. At equilibrium EMF of the cell is equal to 0 now. So E naught of the cell is equal to minus remaining. EMF of the cell is equal to E naught. So take this side. So minus becomes plus. This becomes this side. So EMF E naught of the cell is equal to minus becomes plus 2.303 RT by NF log of product concentration by reactant concentration. We know at equilibrium concentration, this is the equilibrium constant now. So this term is equal to Kc. So E naught of the cell is equal to 2.303 RT by NF log Kc. Temperature 25 degrees Celsius, we can write in Kelvin. So 298 Kelvin. E naught of the cell is equal to 1.1 volt. Now we are going to calculate the log Kc. That is Kc we are going to determine. From this formula, log Kc is equal to, this becomes in the numerator E naught NF by 2.303 RT. 2.303 RT by F is equal to 0.0591. This we already discussed in which one? Nernst equation. So we can replace the term as 0.0591. Log K equilibrium is equal to E naught of the cell into N by 0.0591. This is equal to, so that means instead of this term, we are putting 0.0591 here. E naught value we know 1.1, 2, N, how many electrons is transferred here? 2 electrons by this. So log Kc is equal to this one. What we have to calculate? Kc. So 37.288. So now Kc is equal to antilog of this one. Log K is equal to this term. That means K is equal to antilog of this term. So K is equal to antilog. This whole number should be raised to the power 10 power, no? So remaining we have to take the antilog. That value is around 2. So then into 10 power 37. This value is obtained at 298 Kelvin. So this is the derivation. In general, E naught value is equal to 2.303 RT by NF log Kc. This is our formula. This is the relation between K equilibrium, that is equilibrium constant, and EMF of the cell. By this formula, we are going to solve one problem, that is calculate the equilibrium constant of the reaction. This is the overall reaction. E naught value is given. Now this is the solution. For that we need a formula. What is given here? E naught value, equilibrium constant means Kc or K, we have to calculate. We know the formula. Log Kc, E naught of the cell is equal to 0.0591 log C. Log Kc is equal to 0. That is log Kc can be written as this one. N E naught of the cell by 0.0591. N value we know. How many electrons is transferred? Cu is converted to Cu2 plus, no. So 2 electrons transferred. So we can write N is equal to 2. E naught value is 0.46. So log Kc is equal to, instead of E naught, we are substituting 0.46. How many electrons is transferred here? 2 electrons is transferred. So into 2 by 0.0591. What about log Kc? By solving this, we get this one. Kc is equal to, log Kc is equal to this, means what is Kc? Antilog of this one. So Kc is equal to antilog of, this whole number should be raised to the power, no. So 10 power 15. So antilog of 0.6 value is, Kc is equal to 3.92 into 10 power 15. This is the formula. In this manner, we are going to solve more problems. So what is given here? The problem, we are going to calculate the equilibrium constant. Overall reaction is given and E naught value is given. First we must know the formula. Equilibrium constant means the formula is log Kc is equal to N E naught of the cell by 0.0591. Why don't we write the E cell? E cell is 0 at equilibrium. E cell is 0 at equilibrium. So that only we use this one. So now This is our formula. We need log Kc means this is our formula. What is N represents? How many electron is transferred? 2 electron is transferred. So N is equal to 2. E naught value is given, no. So we can able to substitute directly. From this we solve this and get one value. This is for log Kc. Kc we need means log. To remove the log, you have to take the anti-log of this value. Anti-log, while taking the anti-log, the whole number should be raised to the power, no? So into 10 power 15. And the Kc value is anti-log of this one into 10 power 15. So this is the answer. Now we are going to see one relation between EMF of the cell and free energy. That is electrochemical cell and the Gibbs free energy of the reaction. What is that? Electrical work done in 1 second is equal to the electrode potential multiplied by charge. Electric work equal done by in 1 second. Electric work done in 1 second is equal to, that is, we already studied W max is equal to minus NF E naught. Minus NF E naught of the cell. Minus NFE or NF E naught. This is the electrical work done in 1 second is equal to standard electrode potential multiplied by the charge. The charge means F. That is how many electrons are transferred is N. So we can write like this. This relation is like this. And the reversible work done by a galvanic cell is equal to decrease in free energy. That is reversible W max is equal to minus delta G naught. That is delta G. And therefore, if the EMF of the cell is E, if we find the EMF of the cell as E, and NF is the amount of charge, NF is the amount of charge passed at delta G. That means we can write this as, this is also delta G naught. That means W G naught is equal to minus NF E naught. W max is equal to minus NF E naught of the cell. This is the relation between free energy and this. From this, we are going to find the electrochemical equivalent or the free energy. EMF of the cell is intensive parameter, depends on the intensive. We studied in the thermodynamics intensive and extensive, no, depends on the amount and not. So delta G naught is an extensive thermodynamic property and the value depends on N. Extensive means depends on the N. So Zn gives, this is our Daniell cell, we know, no? Daniell cell equation. Daniell cell equation. N value Zn is converted to Zn2 plus, no, for N is equal to 2. Delta R G is equal to minus NF E naught. N means 2 electrons. So 2F EMF of the cell. But when we write the equation, as 2 Zn2 plus, if it is multiplied by 2 means you have to multiply it by 4. That is 2 into 2. So if the EMF of us concentration of the reacting species is, if the concentration of all the reacting species of this is equal to unity, then E of the cell is equal to E naught of the cell. So that only, that is concentration is unity means EMF of the cell becomes E naught of the cell. That is at standard condition. A naught represents the standard condition. So delta R G naught is equal to minus NF E naught of the cell. We know that is from the Van 't Hoff equation in chemical equilibrium, we derive delta G naught is equal to minus RT ln K. So remove the ln. What we know, ln is equal to 2.303 log to the base 10 K. That is ln is equal to this, not K. So delta R G naught can be written as minus 2.303 RT log to the base 10 K. So instead of writing ln, we are writing in terms of log. So let's see the problem relating this one. The standard electrode potential for a Daniell cell is 1.1 volt. Calculate the free energy, standard free energy, delta R G naught. For this, what is the formula? We know delta R G naught is equal to minus 2.303 RT log to the base 10 K. So delta R G naught we know, this is also another formula. If K value is given means use this. Otherwise you can use this formula. N, how many electron is transferred? N is Zn is converted to Zn2 plus. So N is equal to 2. F we know 96,500 coulomb. And E naught of the value is given. E naught is given as 1.1. Delta G naught is equal to minus NF E naught. No, N value is 2. F value is 96,500. E naught value is 1.1. So we can directly multiply this. This is in joule per mole. To convert this kilo, 1, 2, 3. So 212.27 kilojoule per mole. So in text question, we are going to see the in text 3.6. That is the cell in which the following reaction occurs. This is the overall reaction given. E naught of the value is also given at 298 Kelvin. Calculate the standard free energy. Standard free energy means delta R G naught, and also the equilibrium constant K. Here we have a relation between delta G naught and also K. First we have to find the delta G naught and then the K value. So first write the given details. Given details. What is given? G is equal to, given N is equal to 2. How many electron get transferred? 2 electron gets transferred. 3 2s are 6. 2 2s are 4. That means how many electron? 2 electron transferred. F value we know 96,500. What is the E naught value? E naught value is given, no? That is 0.236. So we substitute here. So multiplying this we get the Coulomb volt. This is nothing but joules. Converted to kilo into 10 power minus 3, 1, 2, 3. So 45.548. This is the delta G naught value. Now another value we have to calculate, no? Equilibrium constant. Log Kc is equal to minus delta G naught by 2.303 RT. How will you derive this? We know delta G naught is equal to minus RT ln K. Ln is converted to log, means minus RT 2.303 log K. And then delta G naught is equal to minus 2.303 RT log A. We need log, no? So log K is equal to minus delta G naught by 2.303 RT. So this is the formula we derived from that 1/2 equation itself. So log Kc is equal to minus delta G naught by 2.303 RT. We know the value R is constant 8.314. Temperature 298 Kelvin. Why we put this 10 power minus 3? It is written in the kilo, no? So we are converting this joule into kilojoule. For R constant, gas constant, no? So 8.314 into 10 power minus 3 into 298. So solving all these we get a 7.983. So Kc is equal to anti-log of 7.983. So this one only we have to take the anti-log, no? This becomes here. So it becomes 9.616 into 10 power 7. Kc value is this one. The Kc value obtained here is this one. So this is the K value. So from this we can able to calculate. We calculated what one? K equilibrium constant and this. So now we are going to see what is this. Why this minus here? This is there is also one minus, no? So minus into minus plus. So that only we don't put here. Delta G naught value is minus. Here also your minus. Minus into minus plus. So we no need to put the plus here. And the next problem we are going to see is calculate the potential of hydrogen electrode in contact with the solution where pH is equal to 10. pH is given instead of E naught. First write the equation here. The pH is equal to 10 means what is the formula for pH? pH is equal to minus log to the base 10 H plus. If it is given in the decimal, if the pH value is given in the decimal means we can use this formula. Otherwise there is another formula, that is H plus is equal to 10 power minus pH if it is a whole number. If pH is a whole number, you can use this one. So H plus concentration is equal to 10 power minus pH. pH value is 10. So H plus concentration is equal to 10 power minus 10. 10 power minus 10. So now EMF of the cell is equal to E naught of the cell minus 0.0591 by N. So EMF of the cell is equal to E naught of the cell minus 0.0591 by N log of 1 by H plus. So we know the standard hydrogen electrode, no? Standard hydrogen electrode, it can act both as a cathode as well as anode. If its value is always, E naught value or E value is always 0. So E naught value is equal to 0. That is E naught value. E naught of the cell is equal to 0 for SHE. So 0, EMF of the cell is equal to 0.0591 by 1. How many electron is transferred? Only 1 electron is transferred. So log of 1 by 10 power minus 10. If pH is equal to 10 means H plus concentration is equal to 10 power minus pH. This can be written as 10 power minus 10. So we are writing 10 power minus 10. So this 0 is neglected, no? So minus 0.0591 by 1 log of, take this to the numerator, the minus becomes plus 10 power 10. So this is equal to minus 0.0591 by 1 this power, anything power is can this side, no. So 10 log 10 value is equal to 1. So multiplying this with 10 we get, but 10 means one value, one decimal comes here. So 0.591 volt. So EMF of the cell is equal to minus 0.591 volt. So these are the questions, these are the problems and the two relations we studied now. And the homework today, copy this PDF as well as do the homework in text, in text question 3.5, in text 3.5, and in book back do the question number 3.4 and 3.6. This is in text 3.5, and also do the book back question number 3.4 and 3.6. Complete this today. Thank you, students.